Okay, so we've got a ladder here. Now with ladders, it's always the same. There's 3 steps you always do. You've got to resolve up and down, left and right, and you can take moments at A. But let's go through, and as long as you have labelled it correctly, these should never ever be difficult. These are like some of the most marks, but the easiest questions. Okay, so we've got a non-uniform rod. The mass is M, the length is 2L. It rests in equilibrium, but the important bit here was it's non-uniform. So what that means is we're going to put mg in, but mg is not going to be in the middle. We don't know what this length is. So we're just going to call this length x, and the whole thing was 2L. So this is going to be 2L minus x. Okay. And we know it's on a rough horizontal floor. So at A, we're going to label R. And because it's rough, we're going to have our friction always going this way. And so that's friction, and that equals mu R, and we're told the mu is 1/4. And if you always write in the mu R, you're not going to confuse your friction with force in general. And then we go to the top, and at the wall, we've got another reaction. I'm going to call that N. And I've got friction as well. So this is the friction at the, wall, which is going to be 2/3 N. I use different letters. You might use RA and RB, but that way I just don't confuse myself. Easily confused, clearly. Right, so now we've got our labelling right. This shouldn't be difficult. We're going to just follow the process. Up equals down, left equals right. Okay, so let's start with up equals down. So going up, I've got this force, I've got this force, and going down, I've got this one. So I've got R plus 2/3 N equals mg. Okay, left equals right. I've got left and I've got right. N equals 1/4 R. Right, so I'm going to call that 1 and I'm going to call that 2. And what I'm going to do is I'm going to sub 2 into 1. So I'm going to get R plus 2/3 multiplied by 1/4 R equals mg. Okay, so altogether I've got, cancel that down, 1/6 plus 1, so I've got 7/6 R equals mg. And then I can simply rearrange that to give me R equals mg, 6/7 mg. So R equals 6/7 mg. And that's going to be the vertical component at the floor. So we're done there. Now we want to find the distance AO. So they've called this point O. I've labelled that distance X. And like we said, we're just going to follow those steps. So the next bit is simply to take moments at A. So we're going to take moments at A. Now, remember, a moment is force times the perpendicular distance. So that's what a moment equals. Right, so we're going to start at A. These forces disappear. We don't care about these. We're going to go up, and the first force we come across is mg. And your perpendicular distance is this bit here. So the distance we're thinking about is this here, because what we say is from A, if we've got this point A and we've got this force going down, from this force going down, I want to go at right angles and meet A. So it's going to be that distance there. Now, that distance there is, this one's opposite, this one that we want is adjacent. Adjacent is always cos. So we've got mg times x cos 60. And then we go further up. And our next force we come across is we've got n and we've got 2/3 n. And if we think about it, if we fix this point, so if we have a point fixed over here, and the mg is going to make it go this way because we're pushing it down. The n and the fr are both going to make it go the opposite way. So they're on the other side of my equation. So that equals n times, and we want our perpendicular distance. So we're going from here, we want to go at right angles until we're sort of in line with A. So the distance that we're looking at here is this distance here, which is opposite. So we've got n times 2l sine 60. So let's just give you, that's equivalent to that blue bit, and that's equivalent to the yellow bit. And then we've got plus 2/3 n times by 2l cos 60, because the distance that we're looking at is then going to be all the way across. So we're taking our force here, and we want to get to A, or in line with A. So essentially the right angle to it is this length here. So all along the bottom. Right. So that's your 2l cos 60. Now what we can do is we can calculate that. So when we substitute it all in, and our distance is going to be in terms of L, we're not going to get a pretty answer. So you don't always get nice answers. The algebra and some of the mechanics questions can be a bit horrible. So we get 1/2 mgx equals sine 60 is √3. We know from what we did previously, n is the same as 1/4 r. So if n equals 1/4 r, that must be 1/4 of 6/7 mg, right? So that's going to give us, if we cancel that down, we get 3/14 mg. Okay, so mg, 1/2 mg equals n, which is our 3/14 mg, times 2l times sine 60, which is √3, plus 2/3 n, and n is again 3/14 mg, times 2l times cos 60. Yeah, so we've got our cos 60, which is 1/2. Right, now if you notice there's mg's in everything, we can cancel them all out. And is there anything else that's in everything? Nope. You don't even have a 1/2. Okay, perfect. So now if I've then simplified that, that's going to give me a 1/2x, which equals then 3√3/14l plus 1/7 l, just putting that in my calculator. We'll multiply everything by 2 to get x on its own, and I'm going to take l outside the bracket in the same instant. And I get 3√3/7 plus 2/7 l. And that is your exact distance. Now, they didn't necessarily ask for an exact distance, but it's going to be in terms of L. If I leave it exact, I'm going to be okay. If they had said exact and you didn't, you'd have lost 1 mark. So that's your ladders question. Up equals down, left equals right. Take moments from A. Always the case, no matter what ladder you do. There's a few more ladders on YouTube. Have a look at those, and we'll look at some other rod questions as well, because it could be any of those.